Okay, welcome to Lesson 5, Video 4. This is some detective work on the partial left test, page 148. This time I will start the button to record. All right, so the partial left test, suppose we kind of think about it as eliminating one variable. So let's go back to our old t-test or null hypothesis that we can get rid of treatment. So beta treatment is 0, it's not necessary, versus the alternative that is not equal to 0. We go ahead and take a look at the treatment, and we get a coefficient of 0.730 and a standard coefficient of 0.038. So 0.730 minus our null hypothesis, which is 0, divided by 0.1388, we get 1.881. And then I go to Minitab and calculate my p-value. I need to use 26 degrees of freedom, because that's the same as the sum of squares of error, and I end up getting a p-value of 0.07136. Kind of keep that in mind as we go to the next one. Now let's do a partial F test. I do the full one with treatment in there, and I get a sum of squares error of 3.446 with standard error of 26 and 1.171, and then I reduce it. Notice that there's no treatment in here and no treatment in here. And there I get a standard error of 34.585. So this one's going to be larger than the sum of squares error for the full. So I take 34.585 minus the 30.446. I eliminated one predictor, so my degrees of freedom there, denominator will be 1. And then I divide by the error 1.171 and I get 3.534. I go ahead and go to my F distribution on Minitab. Degrees of freedom is 1 in the numerator, degrees of freedom is 26. And lo and behold, I get a p-value of 0.07137. It's the same. Wow. Let me just take a little time out here, by the way. Be sure you calculate your F statistic appropriately. You need, and what I would suggest that you do is to calculate the numerator first, and then calculate the denominator first, mean squared errors fall, and then do the division. I just know of so many students that when they enter the data, they end up multiplying by the denominator, or they just don't use the parentheses correctly. Just make sure you use your algebra correctly. I would break this up into 2 or 3 steps so you get the final F statistic appropriately. Back to our regularly scheduled question, notice that the p-value is the same. Let's see why that is. Well, the inference on one coefficient, or t-statistics, was 1.88, and the partial F test was 5.535. How are these two related? Well, I'm sure you've got the answer by now. If you square the t-statistic, you get the partial F statistic. And so if you just remove one coefficient, the t-value squared equals the partial F test's F for removing the one predictor variable. So what if we eliminate all the predictors? Well, basically we're ended up to the overall F test. So you can see that the partial F test is very useful. On one extreme, when we eliminate one predictor, the partial F test is equivalent to the single coefficient t-test. On the other extreme, if we eliminate all the predictors, the partial F test is equivalent to the overall F test. And we're going to continue to use this partial F test as we move beyond to more flexible models, such as polynomial regression and some interaction terms as well. Now, when you're working on homework 19, generally what you do is you run 2 linear regression tests, one reduced and one full, do the calculation, use the formula, make your conclusion. So for example, here's one question: do a partial F test with a predictor variable alcoholic can be removed from the model. So run it with everything including alcoholic, and run it again with everything but alcoholic, and then find your sum of squares errors, and do your division and calculations right out. Be sure that you write a good null and alternative hypothesis. And the same thing, you run the full, and then you remove alcoholic and female, so you have 2. So your degrees of freedom, the numerator will be 2, and then you can do that test at the level of 5%. Again, make sure you have a good null hypothesis and alternative hypothesis, and you will be golden. I have great faith in you. See you at lesson 6.